Hey guys, we are back for page 2 of our final review, and let's start on number 7. We're supposed to identify critical attributes of the polynomial graph. The thing that we should start with is zooming in and identifying all of the x values that are really important. So let's start with this guy right here. That point, x is 1, 2, 3, 4, 5, 6 to the left, so that is x equals negative 6. The next point is at x equals negative 5. Next, we have x equals negative 3. Way down here, x equals negative 1. And our last important point, x equals positive 1. Once we have those x values, then we can find y values if we need to. We can find as much important information as we are asked to find. All right, one of the main things we are looking at on these graphs is where is our graph increasing and decreasing, and how many times does it actually increase and decrease. So starting on the very far left, because we read graphs from left to right, we start by increasing, following the graph up. And then switching over at x equals negative 5, we start following the graph down. And then at x equals negative 1, we start going back up. Okay, we have gone in 3 different directions, up, down, up. And that's really going to help us figure out the type and degree of this problem. Okay, from here, let's go ahead and start actually answering the questions. Okay. The first question asks for type and degree. All right, so we have 5 different degree and type options. First off, if we are going in one direction, okay, one direction, then the type is linear. It's just a straight line. If our graph goes in 2 different directions, we have a quadratic function. 3 directions is cubic, 4 is quartic, like 4 quarters in a dollar, and 5 is quintic. Now, if we go back up to our graph, we notice that our graph went in 3 directions, yellow, green, yellow, or up, down, up. So our 3 directions tell us that we have a 3rd degree cubic function. Okay, so the type is cubic, degree is 3. Next question, min and max. We can kind of find these at the same time, and they have to do with what is our very lowest point for minimum and what is the very highest point for maximum. Okay. So that's really focusing in on a point, and we're looking for highest y value and highest x value. Okay, this point way up here, we've got x equals negative 5, and the y value is the highest in its area. So it's like the top of a mountain. That's going to be our maximum. So I'm going to write max up there. And we also need to find the y value because a maximum is a point. That is 1, 2, 3, 4 above the x-axis. So y equals 4. All right, let's find our minimum. The minimum is the lowest point that's on our graph. That's way down here. And that happens at x equals negative 1. So I'm going to write out min. And we need the y value for it because we need the point. So that's y equals, let's see, 1, 2, 3, 4, 5, 6, negative 6. Okay, so maximum is negative 5, 4, and minimum is negative 1, negative 6. Okay, exactly like we said before, we have the x value negative 1 and y value negative 6 for the min, and for the max, x was negative 5 and y is negative 4. The next thing we're going to focus on is where is our graph increasing versus where is it decreasing. Increasing means that from left to right, our graph is moving up. It has kind of a positive slope to it, even if it's a curve. And then decreasing means that if we move from left to right, our graph is moving downward. Let's look back up at what our graph is doing. Okay, we can see that in the yellow sections, as we move from left to right, the graph is moving upward, and then it stops moving upward when we get to the x value, x equals negative 5. Then we start decreasing for green, and then we start increasing again when x equals -1, and then that goes on forever because we have this arrow over here. Okay. So from the very furthest left, which is -infinity, until x equals -5, and then from x equals -1 to +infinity, we are increasing. Okay. And here's how we write that. Okay. For the first one, -infinity to -5, and then the second yellow increasing section was from -1 all the way to +infinity. Increasing only cares about the x values. Okay, so all of these guys are x values. We know that the y values are getting bigger as we go from left to right, so the x values just say like which section we're looking at. Okay, so if we're increasing from -infinity to -5, and then from -1 to infinity, then that means that in between the -5 and the -1, that's where we're decreasing. So we end up just reusing those same numbers. Take a look. This -5 gets reused down here, and the -1 gets reused down here as well. So we're going from -infinity to -5, -5 to 1, and then from -1 to infinity. And again, these are all x values. Okay, this decreasing part was the green section up on the graph, and the increasing was the yellow. All right, end behavior left and right was one of our favorite things back when we did this chapter. So it is, what is the arrow on the left doing and what is the arrow on the right doing? This is the rising and falling. So this left arrow right here is pointed downward. That means it's falling. The right arrow is pointing up, so that means it is rising. The next thing we're going to talk about is zeros. Zeros are where the y value is 0. We want to know what x values make our y value 0. And this is part of why we figured out all those x values up at the top earlier. So we labeled every single important point on here. So this shows up for zeros where our graph crosses the x-axis, and that is the point at x equals -6, where x equals -3, and where x equals 1. Okay, that's why each of those little equations down there starts with x equals. So we're going to put in -6, -3, and 1. Okay, from there we can figure out the equation in factored form quite easily. We are supposed to solve those equations to get 0. So how would you get 0 on the right-hand side of the equation x equals -6? Okay, you would do that by adding 6 to both sides, and then you would end up with x plus 6 equals 0. Okay. Our factor then is going to say x plus 6. You might see the shortcut here. The shortcut is that you can literally just change the sign. So instead of it being x equals -6, the factor is x plus 6. So that means that the factor in the second one is going to be x plus 3, and that last factor x minus 1, because you would have to subtract 1. All right, let's move on to number 8. Okay, number 8 is all about the square root function. F of x equals the square root of x minus 3 minus 5. And you're going to want to plug this into the y equals part of your graphing calculator, right? So f of x means y equals, so you're going to plug in square root of x minus 3 minus 5. Make sure that the minus 5 is on the outside of the square root, because otherwise it messes everything up and centers your vertex at a weird spot. Okay, so go ahead and get that plugged in right now. Pause the video. And we're back. Okay, the axis of symmetry is the first thing that we ask for on here, and that has to do with the x value. What is the very most important x value? Okay, to find an x value, what we are going to do is do the opposite of the x that's inside that square root. So it says x minus 3. That means our axis of symmetry is x equals +3. Okay, remember that x lies to you. It's just literally the opposite number. Okay, what's awesome about that 3 is it is going to be used in the vertex. 3 comma something. The y value comes straight from that last number, -5. Okay, so the 3 gets recycled, and then that -5 is just the last number. Okay. Now we want to know, is our graph going to stretch tall, compress short, or just stay the same as it normally is? And we can figure that out based on the number that is in front of our square root, a coefficient there. Okay. If it is a 1, that means it is none. Okay, nothing happens because multiplying by none literally does nothing. If you have a number that is bigger than 1, like a 2 or a 3 or a 4 or anything like that, you end up stretching. And if you have something small like a fraction, like a half or 2/3 or anything like that, where the numerator is smaller than the denominator, well, that makes our graph smaller or shorter, so that would be a compression. Okay, you may have figured out then that since that's an invisible 1 in front of our square root, it should be none. So we're going to circle none right there. Okay, domain. Domain is what are all of the x values that we're allowed to have. So we care about x's. That means we're going to use the 3 from the vertex. And the range is y values, so we're going to use -5 from the vertex. Let's go ahead and get the whole graph before we actually draw out that domain and range. X and y, this is where that graphing calculator is going to come in really handy. We are going to find some x and y values from the table. So you've got your equation plugged into y equals, you're going to hit second and then graph to get the table. And I know you're going to get a lot of points that say error or something like that. Just keep scrolling down using the down key, and the very first point that should be available for you is the point 3, -5. And lucky enough for us, that also happened to be the vertex. So this is a really good way to double check that you actually plugged this into your equation right, into your calculator, is this first point should match the vertex that you have up above. Okay, this is also a good way to double check if you remembered to make that 3 the opposite, right? Because it should not be negative, it should definitely be positive. I'm gonna erase that negative. All right. Next, we have the point 4, -4. That is also an option. We don't want any decimals because they're kind of hard to graph, so we're going to scoot on over to the 7, -3, which is whole number points. That's what we really, really want to see. And let's go ahead and get those 3 points graphed on our grid. 3, -5, 1, 2, 3, 1, 2, 3, 4, 5. Way down here. 4, -4 is very close to that. And then 7, -3 is here. Okay, get those 3 points graphed. I would also recommend hitting the graph key at this point so you can make sure that your points are in the same spot as the ones that are on the graph. Okay, and you can see the shape pretty well from there. All right, so we've got this little teapot shape over here, and then we can do domain and range. Domain is our x values. We always start on the left, and the very furthest left point is the x value from our vertex, which is 3. Okay, so 3 up in our domain, and then our arrow is pointing towards the right. Right is towards the big x value, so that is a positive infinity. We always use a parenthesis for infinity, and since our 3, -5, that vertex is a really good point, like it's an actual point, we are going to put a bracket there. Okay, very similarly for the y, we start low and work our way high because we're starting from the least values. Our lowest y value is a -5, and then our arrow is pointing very slightly upward, but it is pointing up, so infinity. And same reasons for bracket and parentheses.